Ever dreamed of visiting another star? Not in thousands of years, but maybe in your lifetime? Einstein told us nothing can travel faster than light, setting a universal speed limit that seems to lock humanity within our own solar system. It's a fundamental rule of the cosmos. The faster you move through space, the more energy it takes, until reaching the speed of light would require an infinite amount of energy. This cosmic speed bump appears to be an insurmountable wall, a firm no from the universe to our interstellar ambitions. But what if the rulebook has a loophole? What if, instead of trying to brute force our way through space, we found a way to cheat the system entirely? What if we didn't travel through space at all, but instead made space itself do all the moving for us? Here's where a brilliant physicist, Miguel Alcubierre, enters the scene with an idea straight out of science fiction. In 1994, while working on his PhD, he took Einstein's own theories of general relativity and proposed a revolutionary concept: the Alcubierre Warp Drive. His mind-bending proposal wasn't about building a faster engine or a more powerful rocket. Instead, he envisioned a method to manipulate the very fabric of spacetime. Imagine a starship encased within a stable, flat region of spacetime, a protective bubble. This bubble would be propelled forward not by conventional thrust, but by warping the geometry of spacetime around it. The ship inside this bubble would technically remain stationary, not moving at all relative to its immediate surroundings. It wouldn't be accelerating or breaking any local physical laws. It would just be along for the ride. This concept is often compared to surfing a massive cosmic wave. A surfer doesn't propel themselves faster than the water they are on. They are carried forward by the motion of the wave itself. The Alcubierre drive works in a similar, albeit far more exotic fashion. The mechanism involves a dramatic manipulation of spacetime. Space behind the bubble would be rapidly and powerfully expanded, pushing it forward from the rear. Simultaneously, the space in front of the bubble would be intensely contracted, effectively pulling it toward its destination. The result is that the bubble and the starship nestled safely inside could traverse vast cosmic distances at speeds that, to an outside observer, would appear to be many times faster than the speed of light. Inside the bubble, however, the crew would feel no acceleration, no g-forces, and no sense of motion at all. They would simply be carried along on this traveling distortion of space-time, surfing the universe. Of course, there's a monumental catch, and it's a big one. To create this space-time bending effect, the Alcubierre drive requires something we're not even sure exists: negative energy, or more broadly, exotic matter. This isn't antimatter, which is very real, but has positive mass and energy. Negative energy is a theoretical substance with bizarre properties like having a mass less than zero, according to Alcubierre's original calculations. Generating a warp bubble large enough to contain even a small spacecraft would require an unbelievable amount of this exotic matter. The initial estimates suggested a quantity with the negative mass energy equivalent to the entire planet Jupiter. Later refinements brought that number down. But the energy requirements remained astronomical, demanding the mass energy of a whole star, but in negative form. This is the central, seemingly impossible problem. We have never directly observed or harnessed negative energy on a macroscopic scale, making the warp drive a fascinating but purely theoretical construct. But the story doesn't end there. The sheer elegance of the idea has inspired a new generation of physicists to keep the dream alive. Researchers at places like NASA's Advanced Propulsion Lab, informally known as EagleWorks, have continued to explore the concept, refining Alcubierre's original metrics. Headed by Dr. Harold Sonny White, the team proposed new warp field geometries that could dramatically reduce the energy requirements. By changing the shape of the warp bubble from a sphere to a more rounded donut-like torus, they theorized that the amount of exotic matter needed could be reduced from the mass of a planet down to something more manageable. Perhaps the mass of a large asteroid or even a car still, a colossal amount, but no longer on a planetary scale. These new models, while still requiring exotic matter, bring the concept from the realm of pure fantasy a tiny step closer to hypothetical engineering. So, can we travel faster than light? For now, the definitive answer is still no. The Alcubierre Warp Drive remains a beautiful piece of theoretical physics. A mathematical what-if, grounded in Einstein's own equations. It is a concept that tantalizes us with the possibility of interstellar travel, but is held backed by our current understanding of energy and matter. We don't know if negative energy can exist in the quantities needed, or if it can be controlled and stabilized if it does. The warp drive is a puzzle with most of its pieces still missing, but it also serves as a powerful reminder that the perceived limits of physics might not be absolute barriers. They could simply be challenges waiting for the right breakthrough, the right new mathematics, a deeper understanding of quantum energy, and a bold, new imagination to see the path forward. No magic, just physics.
Stay curious.